This tutorial is on scientific notation. You can see a bit of an explanation of what's going on in the orange box here. So it's where we have numbers expressed as something times 10 to the power of another something. This is where we have particularly large numbers like billions, trillions, even bigger. Or if we have something very, very, very small, so measuring things like atoms or electrons or the mass of very tiny things, we may have a negative power, meaning it's a really long fraction. It's such a small number that there's lots of zeros before any values. As a bit of a rule, when we're kind of building these, we move to the left with a decimal with a negative power and to the right with a positive power. But it depends on the situation. That's where we're applying these to get them back to normal numbers. So just be careful with that information. You'll see in the examples in just a moment. So here, if we had 9.27 times 10 to the power 4, that's the same as 9.27 times 10 times 10 times 10 times 10. The best way to do this, set yourself up with something like this. You have your decimal there. Just add a whole bunch of zeros out to the right. What I'm going to do is jump my decimal 1, 2, 3, 4 spots to the right, and that's where it's going to go in. So I would now write 92700, and I wouldn't write 0.000, I'd just get rid of those altogether. So it's 92,700 in this case. Question 2, slight change here. We have a negative power. This is where we would be multiplying by 1 over 10, 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 or it's the same as dividing by 10 5 times as well. And again, if we were dividing by 10 5 times, we'd be jumping 1, 2, 3, 4, 5. So that's where our decimal goes. Once again, I wouldn't write 0.0, so I'm going to get rid of these two values here. But notice that that negative does stay out the front. So I'd write this as negative 0.000036. We've just moved our decimal. So this is kind of a shorthand way of writing these, and particularly if we had even bigger numbers than we're dealing with here, this is a good way to go about it. If we're writing the following in scientific notation, this is a slight difference to what we've just done. Here we put a decimal, in this case for 3,600, at the end of our number, and I'm going to jump it to right between these two numbers. You stop when you have a whole number on the left-hand side and no others. So if I went one more, that would be incorrect. I'm going to stop between the 3 and the 6. And I would simply write this as 3.6 times 10 to the power however many jumps I made. In this case, I jumped to the left 3 times, so that is my power here. Let's have another go at that. So decimal, I'm going to jump 1, 2, 3, 4, 5, 6. So 6 spots, meaning that I would write 7.13 times 10 to the power 6. They are exactly the same. If you put 7.13 times 10 to the power 6 in your calculator, it would spit out 7,130,000. This works even if we have a decimal in place already. So if I wanted to write this in scientific notation, I'd be jumping left 1, 2 spots. Not a really great question here, but this will do. 7.652 to the power times 10 to the power 2. Slight change for questions 4 and 5. You can see we're dealing with decimals now rather than large numbers. So we're going to jump to the right 1, 2, 3, and one more, 4 spots. So we've jumped 4 spots to the right. I would then write this as 3 times 10 to the power negative 4. So if your decimal is jumping to the right 4 spots in these instances, we do a negative 4 power. Basically, if it's a decimal, it's going to be a negative power. If it's a number, like a million or whatever, then you use a positive power. You can see the difference in those two there. And last up we have 0.00006541. First step is to work out how many decimal places we're jumping. And I believe that that is 6. And so we would write 6.541 times 10 to the negative 6. So be careful with those powers. Again, because this is a decimal, we're moving to the right, we get a negative power. in this case negative 6. That's it.